Hello, young mathematicians, and welcome to another edition of HISD at Home for Secondary Mathematics. This is the week of May 4th. Remember that if you want to access copies of the activities, they can be downloaded from the HISD at Home website under the resources for middle school parents and students. There, you'll find all of the PBL lessons for your appropriate grade level. So let's get started. This week's in 6th grade mathematics, we're going to be focusing on the following learning targets. Checking to see if you can understand what's a prism and what is not a prism. And then if you can deconstruct the prism and tell me what it looks like from the top, from the bottom, from each of the sides, because we need to be able to calculate the volume of a rectangular prism. And if you want to stretch yourself a little bit, you might want to investigate the difference between the volume of a rectangular prism and a rectangular pyramid. Our guiding question for the week is, how do you find the volume of rectangular prisms? And this is important because you're going to use that information to create a box in order to ship or to hold 100 items. During the week, we're going to ask that you create 2 diagrams that deconstruct the geometric figure or the rectangular prism. There's an image on the screen that models what we want you to do. You're going to use graph paper to draw the 2D deconstruction, which is something we call the net of the rectangular prism. And then we're also going to ask you to define the scale for your drawing. So how much does each unit stand for? Are you having it stand for a ½ inch? Are you having each of those little squares on the graph paper represent a full inch? That's what we mean by the scale. On Monday, the first thing that we're going to focus on is how to define a prism. Remember that a prism has 2 parallel and congruent bases. So we're going to ask you to find household items and check to see which ones are prisms and which ones are not. On Tuesday, you're going to start deconstructing 4 rectangular prisms. So out of all of the things that you collected from around the house, we're going to ask you to focus on 4 of them and to record the measurements for those items in a given table. That's for Tuesday. For Wednesday, you'll actually calculate the volume of the 4 rectangular prisms. Remember that the volume formula is the base area times the height. And this is where we start getting into some really high-level math vocabulary. We're talking about the base area of a rectangular prism. And remember, my base is a rectangle. So I have to find the area of that rectangle, the base area, and I'll multiply that times the height of my prism. In just a few moments, we'll look a little more closely at what we're asking you to calculate. On Thursday is when you start to plan. If you want to have 100 items in one box to ship it away, how are you going to create that packaging? So again, you'll be asked to create a diagram that deconstructs that figure. You're going to use the graph paper to draw that net or that deconstruction, and again, define the scale of your drawing. We've listed out the steps to creating the box on that checklist for Thursday, because then on Friday, we're going to have you create the final draft of your image. So again, remember your must-haves. A diagram that deconstructs the figure that you've drawn on graph paper, along with the scale for your drawing. And don't forget, the whole goal is to calculate the volume of the box. So again, just to recap, 6th grade students are asked to create a box that contains 100 items and calculate the volume for this supersized box. So let's look just very quickly at some ways that you could do that. See you back in a bit. All right. For 7th grade mathematics, we're going to return to the robots that we created last week. I sure hope you saved yours. Remember, my robot's name was Tiny Todd. We're going to focus on finding the surface area of prisms and pyramids. And to do that, we're going to ask you to use the nets. And when I look at the net of the prism or a pyramid, I'm going to notice that it's a set of composite figures. Some of them have rectangles, triangles. If it's a really nifty design, it might have trapezoids or parallelograms. But because we learned how to calculate the area of each of those separate figures in 6th grade, we're now going to use them in conjunction together in a composite figure to determine the surface area of a prism or pyramid. Now remember, prisms have 2 parallel congruent bases, and pyramids only have 1 base. That's important because by having 2 bases, that means that the lateral faces or the sides of a prism are all parallelograms or rectangles. For a pyramid, because I only have 1 base and a vertex, that means all of my faces are triangles. So that's important to remember as we move on through this project. The guiding question is, how do you find the surface area of prisms and pyramids using nets? And remember, nets are what the figure looks like if it's laid out flat. You're going to create a robot, and you can either draw the robot or you can actually create one, or you just use your robot from last week. Remember that the robot has to have at least 5 figures to represent the head, arms, body, and legs, and we're asking that it be made of prisms or pyramids. You're going to write down the name and measurements of each of the shapes for the component pieces, and then you'll calculate the surface area of each part of your robot and use that information to calculate the total surface area of your robot. On Monday, we're going to review how to calculate the area of composite figures. On Tuesday, we're going to start calculating the surface area of prisms. So we're going to put that information and that knowledge to work about composite figures because you're going to deconstruct the prism into the net and list out each of the pieces of that net as a rectangle, as a triangle, and you're going to use that to calculate the composite area. On Wednesday, we're going to calculate the surface area of pyramids. And again, don't forget, our focus is on using the nets. On Thursday, we're going to give you a full review of how you determine the surface area, no matter whether I give you a prism or a pyramid, or it could be anything. I do want you to remember that lateral surface area is just around the sides. It does not include the bases or the base. Total surface area calculates all of the sides or the lateral surface area, and it includes the bases. Remember, prism has 2 bases, while a pyramid only has 1 base. So when we're calculating total surface area, it's going to depend if I have a prism or a pyramid as to how many bases I'm adding in. And then on Friday, I'm going to actually calculate the surface area of my robot. I've got to have at least 5 figures. I'm going to ask you to write down the name and the measurements of the shapes of each component figure, and then calculate the surface area for each part and the total surface area of the robot. So just to recap, 7th grade students, you're going to create a robot and you're going to calculate the total surface area of that robot. Remember that it has to have at least 5 figures. We need a head, arms, body, and legs. You need to use prisms and pyramids to make your robot. Write down the name and measurements of each of the component shapes, and then use that information to calculate the surface area of your robot and each of the pieces. So let's review very quickly using my robot from last week, Tiny Todd. See you back in a bit. Do you remember Tiny Todd from last week? I introduced him to you. This is Tiny Todd. Now remember, he has lots of different pieces. He has his head, he has his body, he has 2 hands, and he has 2 legs. Now today in the 7th grade project, we're asking you to calculate the surface area of Tiny Todd. And I want to focus for just a moment. Let's focus on his body and his hands. I'll need to calculate the surface area for all of the pieces, but right now I just want to focus on his body and his hands. Let's look at his hands first. So when I look at Tiny Todd's hands, he actually has rectangular pyramids. Remember that I'm going to fold them up in order to make each of the hands on either side of him. So I have a rectangular, because that's the base, pyramid. Remember that pyramids only have one base, and all of their lateral faces or their lateral sides are triangles. So in order to find the surface area, we look at the net. So one of the things that I can find the area of is this rectangle right here. I can find the area of a rectangle. And that's actually the base. Then I would need to find the area of each of the lateral faces or each of the sides. And those are all triangles. So I have 1 triangle, I have 2 triangles, I have 3 triangles, and then I have 1 more. Now you might notice that all of these triangles are congruent, or they're equal to each other. So once I find the area of one of them, I'll be able to use it for the other areas. Now, do you remember how we find the area of a rectangle? That's correct. I'm going to take the base times the height. That's how I find the area of the rectangle, and that's the bottom base. That will give me the surface area of this piece. Now, to find the area of a triangle, do you remember what that formula is? That's right. It's 1/2 base times height. And that will be the same for all of them. 1/2 base times height. And remember, they're all exactly the same. So I really only have to find one of them, and I can use its answer for all 4. Now, what's very important, you're going to have to think about this, because when I'm calculating the surface area of Tiny Todd here, is the base of this rectangular pyramid, is it facing out? It's really not. It's right up against his body. So technically, I know that he has a rectangular pyramid for his hands, but the rectangle is not facing out. For Tiny Todd, I really just want to find the lateral surface area. So if I'm just looking for the lateral surface area, I do not need the area of the base. I just need the added or summed total of the 4 triangles to find the lateral surface area. And that would give me the lateral surface area for Tiny Todd's hand. And remember, this is only for one hand. I'd have to do it again to find the lateral surface area of the other hand. And just to make sure you know they're congruent. So once I find this one, I can multiply it by 2. Now, I'd like to look at Tiny Todd's body. Tiny Todd's body is shaped like a rectangular prism. So remember that it is a box. So when I find the surface area of this rectangular prism, keep in mind, I do not have the little base here and the little base here that's right up against the rectangular pyramid. So when I calculate the lateral surface area for Tiny Todd, I really just need the area of this rectangle, this rectangle, this rectangle, and this rectangle. Ooh, how about I label them correctly? Rectangle 2, rectangle 3, and rectangle 4. This will give me the lateral surface area. And I do not need to find the area right now of the two bases, because when I put Tiny Todd together, those bases do not face outward. That's how I attached his hands. So keep that in mind. You have to be able to calculate lateral surface area. If I had wanted the total surface area, I would find the area of each of these rectangles as well as this one, and then I'd add them all up. But as you're calculating the surface area of your robot, you need to be careful to see which pieces are actually facing the outside. So be careful and hope you have some fun calculating the surface area of your tiny robot.
Welcome back. The project for 8th grade mathematics is very similar to the project for 7th grade. We're asking you to solve problems involving surface area, but you need to understand how to calculate not only the surface area of prisms and pyramids, because you're bringing that information and knowledge from 7th grade, but we're expanding it to include cylinders. Our guiding question is, how do you find the surface area of 3D composite figures? And how do we relate the surface area formulas to the surface area of nets? Remember that we're using the robot we created last week, or the drawing we created last week, and I'm using Tiny Tanya again. Just like with 7th grade, it has to have 5 figures. You need to write down the name and measurements of the shape of each component object, and then calculate the surface area for each part of your robot, and then the total surface area. On Monday, we're going to review how to calculate the surface area of rectangular prisms, just in case you don't remember from 7th grade. On Tuesday, we'll review how to calculate the surface area of triangular prisms. On Wednesday, you'll review how to calculate the surface area of cylinders. Now remember, this is the new knowledge and the new understanding for you students in grade 8 this year. On Thursday, we'll review how to do surface area calculations for any of the figures. And then on Friday, you're either going to create your robot or use the one from last week and calculate the surface area. To recap, students are going to create a robot utilizing 3D figures, and then you're going to calculate the total surface area of the final figure. Remember that the robot needs to have at least 5 component figures. It's got to have a head, arms, body, and legs. You need to write down the name and measurements of each of the shapes and give me the measurements for each of those components, because we need those to calculate the surface area of each part and then the total surface area of the robot. So let's review. For this week of May 4th, our 6th graders are creating a box that will contain 100 items. In 7th grade, you're going to measure the surface area of the robot that you created last week. And in grade 8, you're going to create a robot and calculate its surface area. Hopefully you still have the one from last week. So what I would like to do now is just pause for a moment and let's check out and review. How do you calculate the surface area of a cylinder? And then we'll be back at the end.
For the 8th grade project, we're now calculating the surface area of your robot. And do you remember meeting Tiny Tanya last week? Tiny Tanya is a friend of Tiny Todd. They look very similar, But there's a difference between Tiny Tanya and Tiny Todd. Can you see what that difference is? Do you notice the difference? That's right. Tiny Tanya has a cylinder for a head. And I'm going to take her apart for just a second so that you can see her a little more closely. So Tiny Tanya has a cylinder for a head. And she actually has a cone for a hat, but I want to focus on her head for just a moment. What we've done is we've rolled up an image that looks like this. Because when I calculate the surface area of Tiny Tanya's head, this is a little bit more difficult than when we were doing the other problems. Tiny Tanya's head is made by rolling up the cylinder and then closing the top and the bottom. Now, just like we talked about with Tiny Todd, this part of her cylinder is taped to the body, so I do not need to calculate this circle portion. The top portion is underneath her hat, so I don't need to calculate that either. But what I do need to calculate is this big rectangular piece that creates the lateral surface area for Tiny Tanya. And this is a little tricky, so let's look at it very carefully. Do you remember what we call the distance between one base and the other base? That's correct. It's the height of the cylinder or the height of the prism when we're talking about shapes that are polygons. So we can easily find the height for Tiny Tanya. Now, that's one part of my rectangle. But how am I going to find this base length? How do I find this? And I want you to think with me for just a second what this distance along the edge of Tiny Tanya's head might represent. Do you agree with me that when I roll this up, that the distance along that rectangle is the distance around the outside of this circle? The distance around the outside of the circle is how I roll this all the way around to make my cylinder. And you're going to have to think back, how do I find the distance around a circle? Now, this is tricky because we have two formulas that look very similar. One of them calculates this distance around the circle. We call that special measurement of the distance around a circle the circumference of the circle. And the formula for the circumference around a circle is 2 pi r. So in order to find the lateral surface area of Tiny Tanya's head, I need to calculate the area of this rectangle. And that is measured by the height times 2 pi r. And notice that I'll get the radius from the radius of Tiny Tanya's head. Now that helps me with her head. For the other body parts, because of the way that I made Tiny Tanya, I can figure those out with the rectangular prism and the rectangular pyramids and even the triangular prism. If you're not sure how to calculate the surface areas for those, go back and look at the 7th grade portion of this or last week's videos. Thank you for joining us today. Tiny Tanya and I appreciated your work. There was a lot of really difficult things to think about today because you have to be careful and consider what is showing on the outside and if I need to add that in or not. Thank you again. My name is Alyssa Howell. I'm the Secondary Director for Mathematics in Houston ISD. Tiny Tanya and I hope that you're safe and healthy. Thanks.